2 2/3? Just one? All right, man. Adam's the man. All right, one way you can do it. I'm glad nobody said 12, and if you said 6, don't hold your answer to yourself, okay? If you said 6. Okay, you're not going to cut it, take the average. Okay. Now, think about this. After 1 hour, how much has been completed? Okay, your mom, it only takes 4 hours. You take 8 hours. So how much will have mom completed after 1 hour? 1/4, right? So it takes her 4 hours, 1 hour. So she'll have completed 1/4. How much will you have completed? An 8. 8 hours, you did an hour, so you did an 8. So an 8 is you. So how much total have you done? Mom's finished a 4th. You've done an 8. What's a 4th plus an 8? 3/8. So after 1 hour, you're 3/8 finished. Now that's good that you can say, all right, after 2 hours, it's 6/8. And after 3 hours, it's 9/8. So I got to finish somewhere in between 2 and 3. So that's good. But think about this after 1 hour. So you got that 3/8 times the number of hours has to equal, this is like a little bit of an equation you can set up. 3/8 times the number of hours has to equal what? To get this solved? 1. Good. Now, how do you solve that? 3/8. Multiply by 8 over 3, which is going to give me 8/3, which is 2 2/3. So that's where you get 2 hours and 40 minutes. Okay, for that one. Now we're going to go over how to solve this. There's a little formula to help you, and once you know that formula, it makes things a little bit easier for that. But that would be the case. And sometimes you can just pick it up intuitively. Adam, did you do anything like this?
I thought of it as 0.125x plus 0.25x for an 1/8 and a quarter.
Okay.
And have it equal 1.
Got it. And so then you got 3/8, which is 0.375. Took 1 divided by that, and you got 2 2/3. Okay, good. Excellent. So there's different ways to do that and solve it. All right, homework-wise. 54 and 56. Those are your answers for 54 and 56. All right, if you double check them. I will do 79 next. A lot of you did it right, which is good. Justin, you checked me and Brandon. Oh, I did not. I did not give you guys notes either. And
I have to save my phone out for 18 lines or something.
Let's see. Did you die for it?
Oh, wait. Okay, questions here on anything before 79? Anything before 79? All right, good deal. And 70, now the answer in the back, what is it? X equals B minus A? Mm-hmm. And they give you a little condition, and they say A cannot equal negative B, or B cannot equal negative A? B can't equal negative A.
All right, B cannot equal. I'm not worried about that. I just need the X equals B minus A. I'll explain why it says that, and when you'll see that occasionally. It's like a really fine detail, and like I said, I'll explain. All right, to solve this, we're solving for X. I got an X over here. I got an X over here. You got to distribute in. You cannot subtract that X. You cannot move it out of that parentheses. So I get A squared plus AX equals B squared minus BX. Well, you got to follow just your general principles. If I'm solving for a variable, solving for it, you get everything with that variable on one side and everything else on the other. So I got to get
everything with an x on one side, all the other values on the other. So I'm going to add bx. So I'm going to get ax plus bx. And I'm going to subtract a squared. So I get b squared minus a squared. Okay. Added bx to both sides. Subtracted a squared to both sides. If you have more than one term with the variable you are trying to solve for, you have to factor that variable out. Key step here. It seems like most of you are doing pretty good because you're getting the other ones right, but I want to really emphasize that. So you factor out the x. And so you get x times a plus b equals b squared minus a squared. Divide by a plus b. Divide by a plus b. And I get x equals b squared minus a squared over a plus b. Now, some of you had this, that you have not made a mistake. You just didn't finish. You didn't finish. You didn't get the answer. That's why, again, I'm going to emphasize, hey, check things out so you see like the form that is written. Also, here's why it says b cannot equal negative a. If b would equal negative a, then you would get 0 in the denominator. They're always going to do that. Anytime there's a fraction in a problem, it can never equal 0 in the denominator because that's undefined. So they'll give you that condition. Like I said, that's the detail. Okay, I understand it, but it's not really the meat of the problem. Well, how do I go from here to b minus a? You got to factor that top. B squared minus a squared is a difference of squares. X equals b minus a times b plus a. You don't need to rearrange it. I think sometimes we get brainwashed and thinking, oh, it has to be a squared minus b squared. No, it doesn't matter. Like if you do that, then you got to mess with the negatives. It gets messy. Just do b minus a times b plus a. You get a plus b here. You can only cancel entire expressions. Like you got to watch. You cannot cancel that b and that b and that a and that a. That really doesn't work. You might say, well, it gave me the answer. Well, that's just pure luck. Okay, because that doesn't work. You got to cancel entire expressions. So a plus b and b plus a will cancel. That's where we get b minus a here. And even though that denominator cancels, it doesn't matter. It was in the original problem. You still have to say b doesn't equal negative a. Now, I'll never mark off if you don't write b doesn't have to equal negative a. That, like I said, that's just a little detail. All right. But I just need to see that. This is the main thing I'm looking for. Okay. All right. Anything else from that homework? Okay. All right. Good. Good. That's an important one because we do a ton with like literal equations, solving for variables. All right. We're getting into section 1-2. It says application of linear equations. It's a fancy word for word problems.
You didn't give me any guided notes.
Well, let me give you some. Okay. We'll cover your books tomorrow if you haven't already. So if you do have a paper bag, bring it. If you don't, I do have some extras that I can let you use, but that'll be kind of one of the goals for tomorrow. All right. Okay. All right. We're going to use linear equations. Equations in one variable solve these problems. And sometimes there's different ways to solve them, just depending upon the situation. Before I get started on those problems, there's 3 kind of equations that come up that will help you. You can put them at the top, or you can put them, I don't know, somewhere where you need them. But you don't need to write all that information down. Just I equals PRT, interest. Interest equals principal times rate times time. Principal is how much money you either have borrowed or how much you have in a bank. Interest can be positive or negative. If you have a credit card, interest is money that you owe. Okay, if you have a savings account, interest is money that you get. Okay, so it all depends upon the scenario. If you've charged $15,000 on your credit card, that is the principal. Rate always needs to be a decimal. So if it's 2%, make sure it's 0.02. If it's 20%, make sure it's 0.2. Okay. So that is one case. Any physics people in here? Okay, all right. So physics is applied math. Okay, that's what it is. So you take different scenarios, you take different situations, and it's basically all math. One thing you'll use a lot of is distance equals rate times time. Okay, so that comes up. And that's a pretty common one. So that's D equals RT. Now the third one is one we'll use to solve basically the lawn mowing problem we had. It's called a work rate case. If you got two people or machines that take a certain amount of time, how long will it take them to do it together? Bless you. What I showed you and kind of what Adam did can boil down to what we call T over A plus T over B equals 1. Okay, because it has to equal one job. Time it takes for two people working together is T. A is the time it takes for a person or machine to complete the job working alone. B is the time it takes for a person or machine to complete the job other one. So, somebody's on a 0-turn mower and somebody's on a push mower. They're not going to get done in the same amount of time. But you can figure out the final. All right, we good there? All right, once you have that down, read through number 1. Read through number 1. Now, the first one doesn't use any of these equations. All right, this problem could be done with a system of equations. Some of you might say, well, could we do a system? We're not going to today because it says linear equations in one variable. So we're going to make this a linear equation in one variable. All right, before we go any further, don't write this part down, but just pay attention. 32,000 people at the ball game, right? They're either reserved or general admission, correct? So the number of reserved seats plus the number of general admission has to add up to what? Okay, number of reserved plus general admission has to add up to what, Brandon?
200,000.
Now 200,000, that's the money.
Oh, 30.
30.
32,000.
There we go. The number of reserve plus the number of general admission has to add up to 32,000. Okay, so that means that the number of general admission will be 32,000 minus the number of reserve. Correct? Can we agree on that? All right. Now you can use that as part, but here's what I'm going to go over here. And I'm going to say, all right, I'm going to say reserved. My reserved seats, I'm going to call X because I don't know what it is, do I? In general admission. So then if that is X, how can I represent the general admission? I don't want to use another variable. I still want to use that X. Okay, I don't want to introduce another variable. So think how that is. So general admission is 32,000 minus the number of what? Reserved seats. Well, what did we say the reserved seats are? X. So it's going to be 32,000 minus X. Does that make sense? I hope I didn't confuse you by doing that. If two things add up to a certain amount, one of them's X, the other one's the amount minus X. So those two add up to 32,000. This is mathematically why it's 32,000 minus X. All right, now think about the 200,000. Think about the $12 and $4. Now, how do I combine those two into an equation? Okay, so for each reserved seat, you get how much money? 12. So how much money do we get from the reserved seats? We get 12 times the number of seats sold, which would be represented by 12x. How much money do we get for each general admission? 4. So 4 times the number of general admission seats. Well, how many general admission seats did we sell? 32,000 minus X. So it's going to be 4 times 32,000 minus X. And what does that amount, what do those two amounts have to add up to? 200,000. So it equals 200,000. All right, that's the hard part. Hopefully. You solve it from there. Go ahead. Solve it. Make sure you answer the question asked. Make sure you answer the question asked. Matthew, let me know what you get for X when you're done. Done? What'd you get?
9,000?
All right, he says 9,000. So see if you get the same thing. Let me just kind of work up here. So I get 12x plus, what is that, 128,000? 128,000 minus 4x equals 200,000. And so 12x minus 4x is 8x. Subtract 128,000. And then I get 8x equals 72,000. Divide by 8. And yes, it looks like I get 9,000. All right, you got to make sure you read the question because it might say, how much money was generated from general admission or whatever. But in this case, it just says how many people were reserved, how many people were general admission. So reserved would be 9,000, and then general admission would be 23,000. Okay, so just make sure you identify that. Just don't stop at x equals 9,000. Okay, make sure you identify what it asks for. So reserved 9,000, general admission 23,000. Reserved. All right, go ahead and look through. Oops, not money. Number 2. Okay, Marty received inheritance, $70,000. All right, so boom, she gets a lump sum. She invested part of 7%. So she took some of that 70,000, put it in some vehicle that gives her 7% interest, and deposited the remainder in tax-free bonds at 10%. This is an interest problem. It's kind of implied. It doesn't. You don't see the word interest in there, but you need to be able to figure that out. Her total annual income from the investments was $5,500. Find the amount invested at 7%. All right. The annual income, this is the amount from the interest. Her interest, I'll just call it I1, plus her interest from the second one has to add up to 5,500. Okay, has to add up to, so interest. Interest is principal times rate times time. Well, since it says annual income, that means our time is 1 year. So T is 1, so it just becomes principal times rate, whatever our amount is. All right, so how much did she put in the 7% account? And how much did she put in the 10% account? All right, how much did you put in the 7%? How much did she put in the 10%? Justin, you with us?
Yeah.
Okay. What do you think? How much did she put in the 7%? How much did she put in the 10%? I don't either. It doesn't tell us, does it? So how do I represent it? It's a total of 70,000, right? I can tell you that. All right, well, we're going to have to let something be X. So the amount at 7%, let that be X. What's the amount at 10% have to be?
70,000 minus X?
70,000 minus X. So if you have two things that add up to a number, they both add up to 70,000. One of them is X, one of them is 70,000 minus X. So yes. All right, that's your amount. Well, interest is the interest rate times the amount. Well, the interest rate is 7%, so the interest from the first one is going to be 0.07 times X. So it's going to be 0.07 times X plus The second one's going to be the interest times the amount. Well, what's the interest of the second one? It is 10%. So you can either make it 0.10 or 0.1. Doesn't matter. Times 70,000 minus X. That has to equal 5,500. Okay. All right. Solve it. See what you get. Adam, have you ever played Pac-Man?
Yeah.
Yeah? Okay. Or after?
Like an actual arcade box. There's a place down in Akron, like the valley part of the city.
Uh-huh.
I think it's called Quarter Up. It's like a bar arcade. And it's open to minors, I think, Saturday and Sunday. The rest of the time it's 18 plus.
So you've been to play Pac-Man?
Yeah, it's like a arcade.
Yeah.
It's all like 80s, 90s machines.
Play this Pac-Man?
I think so.
How about Galaxy?
No.
Oh, try again.
I like playing Asteroids.
Oh, Astro. Oh, the old. Oh, yeah. That's. You used to play that at the bowling alley. That's right. Astros. Never very good at it. What else? Anything else? Are you doing pinball? They got pinball there?
They do.
They do.
Probably like 10 different machines.
I'll have to check it out. Brooke, let me know what you get when you're done. Sorry for disturbing. I think I said it earlier, but I will get you your quizzes back tomorrow. They are not completed yet. Got an answer?
50,000?
50,000, I think we agreed? I think it's 50,000. All right, so we'll just double check here. 0.07 minus 0.1, make sure you make that negative 0.03. Okay, plus 7,000 equals 5,500. And then subtract 7,000. And I get negative 0.03x equals minus 1,500. Divide by negative 0.03. And then I get, what is that? We said 50,000, right? Now, all right, make sure we answer the question. Find the amount invested at 7%. Well, that is the amount invested at 7%. 20,000 at 10%. So the amount at 7% would be 50,000. 20,000 at the other one. Maybe the other one's a little bit riskier. You don't want to, you don't want to put the majority of it in that. Do something a little bit safer. All right. Number 3 down there. From a point on the river, 2 boats are driven in opposite directions. One at 6 miles per hour and the other at 12 miles per hour. In how many hours will they be 54 miles apart? All right, we got distance, we got time. What formula are we going to have to use? D equals RT. So that's going to come up. Distance equals rate times time. Now, these are all different problems. Here's the one thing you got to watch. Just like in physics, you rarely have 2 problems that are exactly the same. Each one's a little bit different, which is either fun or maddening. Okay, depending upon that. So the same thing here. I can give you a couple examples, but there's going to be other examples. You cannot just follow the same format. This one is really not that hard. Guess and check. Like, you can figure this out, not that difficult. But I still want to come up with an equation. I still want to do that. All right, they're going in opposite directions. One is going at 6 miles per hour. So I'm just going to put over here D equals RT just so I have that. One is going at 6 miles per hour. One's going at 12. So let's say the distance covered will be 6 times the number of hours traveled. So 6H will give me that distance traveled. Okay. The other boat's going 12 miles an hour. That's 12H. They say they will be now after a certain time, they will be 54 miles apart. Take a look at that information. Give me an equation. Logan, any ideas?
I know 54 has got to be the distance.
Got that. You got it. Mackenzie, any ideas?
Not really. I just have that you're solving for the time.
Okay. Holly?
Would the rate be 6H plus 12H?
Okay. Yes, that'll be because these will be the two distances. So if you think about this as distance 1 and this is distance 2, those two distances have to add up to the total distance of 54. So in this case here, 6H plus 12H has to equal 54. So that's what I would use. Yep. I'm not saying it's the only one, but that works. Now, this ends up being a pretty simple equation. 6H plus 12H is what? 18? 18H has to equal 54. So essentially, after each hour, they'll be 18 miles apart. Okay, this one went 12, this one went 6. Then you could just keep doing that and figure it out. Divide by 18. Divide by 18. And I get H equals 3. So how long will it take and how many hours? 3 hours. Okay, 3 hours. So that's a distance problem, rate and time. So like I said, they're going to be different. All right, flip it over. Now, if you look at that one, this is like the very first one we did. This is a work rate problem where you got two people doing a job and they say, all right, how long will it take them to do it together? Okay, Frank can type a report in 2 hours. James can take 4 hours to type it. How long will it take the two of them typing together? Let's use the formula. Let's use the formula, which is T over A plus T over B equals 1. I'm going to solve this just a little bit different. I'm going to set it up the same, but then I'm going to solve it just slightly different. Okay. Like after 1 hour, this one would be a half done. The other one would be a quarter done. Like you can do it that way. Okay. But now in this case, let's use the formula. We don't know the total time, so that's going to stay as T. A is the time it takes one person. So I'm going to make that T over 2 plus T over 4 equals 1. You could make this like a decimal or a fraction in front of T, but here's what I want to do. I want to get rid of fractions just to make it a little bit easier. I know a lot of you don't like them, so sometimes we'll just take care of them and eliminate them. What can I multiply everything by to get rid of the fractions? Okay, take your biggest denominator, the one that everything will go into, which would be what? 4. Multiply everything by 4. So I'll multiply this by 4, this by 4, and this by 4. And when I do that, you cancel, you end up with 2t plus 1t equals 4. And so now I get 3t equals 4, divide by 3, and I get t equals 4/3 of an hour, or 1 hour, 20 minutes. Okay, 20 minutes. Then we're good. Okay, for that. Now, before we do that last one, these type of problems come up a lot. Make sure you deal with some of them times in chemistry. You get things of different percents. You want to create something new by combining two of them to a new percent. Okay, depending on what you're looking at. I'm just going to, this is not on your notes, so just pay attention just to understand it. Using OJ, orange juice. You got 10 liters of 50% orange juice, which means half of it is, 100% orange juice. You got 20 liters of 20% OJ. You add that together. Obviously gives me 30 liters, right? What percent would I have of orange juice? Take a second and you see if you can figure out what percent. I'll explain it in a second. Okay. Is it 10%, 20%, 30%, 40%? What percent is that mixture? All right, take a second and see if you can figure that out. Katie, you got it?
Maybe.
Maybe. Well, of course it's a maybe. What do you got?
I think it's 30%.
It is 30%. It is 30%. I just need you to understand the basics. Now, here's why. Here's why. You got 10 liters at 50%. How much pure OJ do you have? Like if you separate it out into OJ and water. Matthew, how much pure OJ would we have?
5 liters.
5 liters. So we would have 5 liters of OJ, pure OJ, orange juice. Plus, all right, Matthew, 20 liters at 20%. How many liters of pure OJ do we have?
4 liters.
4 liters. Take 20% times 20. 0.2 times 20, give me 4 liters. So 4 liters of pure OJ. Well, you add that together. Okay, so when you dump it all together, you have how many liters of pure OJ? That can't change. You have 9. So you got 9 liters of pure OJ. All right, 9 out of how many? You have how many total liters? 30. So 9 out of 30. So that is where you're going to do, 9 divided by 30, 0.3, 30%. So you got to understand just the basics there. You understand the basics. All right, now look at that last one. Look at that last one. And it's not going to be in the exact same format. Now, I'm going to give you a chart to help you organize your information. Some people really like it and use it. Some people don't use it at all. You don't have to use it. Okay? So here's kind of how it boils down to. We want to know like how much pure alcohol or pure orange juice, or like you get 14 karat gold, how much pure gold, like in chemistry you're dealing with different chemicals. So we want to know how much of that element you have. So if you take a look at this chart, I would copy it down at least once so that you have it. We need to how many liters, we know what percent, and then we need the total liters of alcohol, which would be in this case, like the last one, total liters of orange juice. Okay. All right. How many liters of a 20% alcohol solution must be mixed with 30 liters of an 80% solution to get a 40% solution? So it doesn't tell us how many liters that last solution is. It depends upon the first two. All right, I will fill it in and I'll explain where everything goes after that. Okay. So you got your 3 things. You got your 2 that you're adding together and you got your final mixture. All right, for the 20% solution, how many liters are we using? Doesn't say, does it? So what do we got to put there? Just put an X there. It's an unknown. So put an X there. Well, is a 20% solution, that means it's 20% alcohol, which is 0.2. To get the number of liters of alcohol, it is always percent times amount. That's kind of like what you did on the last time. So 50% of 10 liters, 0.5 times 10 gives you 5, although most of you just did that in your head. So the total liters of alcohol is 0.2x. 0.2x. I don't know how many liters were given, so I guess got to write as 0.2x. All right, 80% solution. How many liters are we given? Do we know? Yeah. 30, right? 30 liters. So the number of liters is 30. It is 80%, so it is 0.8 or 0.80. The amount is going to be 0.8 times 30. Yeah, I know you could have multiplied that out and put 24. I'm just going to write it like that, though. All right, my final mixture. This is the key step here. How many liters is the final mixture? Yeah, we don't know. How do I represent it mathematically?
30 plus x.
30 plus x. Now, I like x plus 30, but 30 plus x is the same thing. So I'm going to say x plus 30. Whatever you just add them together. X plus 30. What is the percent? They tell us the percent is 40%, which is 0.4, right? And now how do you represent the final amount? 0.4 times, in parentheses, x plus 30. All right, we got everything here to give me the equation that we'll use. Anybody know what the equation will be from this information? Think about what we did before. The amount of pure orange juice of the two mixtures has to add up to the amount of pure orange juice in the last one. Your last column is your equation. It's going to be 0.2x plus 0.8 times 30 equals 0.4 times x plus 30. Okay? All right, solve that. See what you get for x. And then that would probably be, I think that'll be what we need for a final answer. How many liters of 20%? So you're taking how much pure alcohol is in your first solution plus how much pure alcohol is in your second solution. That has to match up with how much is in your final solution. And let's see here, 0.2x plus 24 equals. Anna, let me know what you get when you're done. You get 60? All right. Anybody else get 60? All right, I got a couple head nods. We'll go with that. So I'm going to subtract 0.2x. I'm going to subtract 0.2x. And then I get 24. That gives me 0.2x plus 12. Subtract 12. 12 equals 0.2x. Divide by 0.2. X equals, so 60 liters. That looks bad. 60 liters of, what is it, 20%? Okay. There you go. All right, good. All right, I got a little bit of bad news here. Unfortunately, I'm not going to give you homework. So I apologize. I'll try not to let that happen too often. We'll pick this up tomorrow. We'll do a good bit of in class. Like the assignment won't be in class because I want to be here to help you if you need it. Bring get a book cover. Bring that. Otherwise, we'll do a little stations and have you do a book cover, 4 or 5 at a time. All righty. Don't tell all the other classes. I don't want them to get, in case I decide to give them homework.
You should show them all of them.
I know.